James Gleick, Genius, The Life and Science of Richard Feynman. Welcome to the intriguing life and unique wisdom of Richard Feynman, a physicist of extraordinary brilliance. In this book summary, you will explore how Feynman's early life shaped his genius for visualizing complex challenges, a genius that would eventually earn him a Nobel Prize. Learn about his work on the Manhattan Project, his unconventional thinking, and his contributions to the field of quantum mechanics, as well as his personal life with all its quirks. Dive into the mind of a man who broke conventional barriers in science and education, and prepare to be inspired by the passion and curiosity that guided his life.
Feynman's scientific upbringing. Richard Feynman's father, Melville, predicted that his son would become a great scientist and made sure to nurture his scientific mindset from an early age. Melville used creative methods to teach Richard about the world, emphasizing the importance of understanding the how and why behind things. This upbringing shaped Richard Feynman's approach to science and education throughout his life. Even before Richard Feynman was born, his father Melville had a vision for his future: he would grow up to be a great scientist. Although Melville's own scientific aspirations were curtailed by societal limitations, he dedicated himself to cultivating his son's intellectual curiosity and gifts. Richard Feynman's formidable scientific mind was nurtured from infancy. While he was still a baby, Melville stimulated his son's brain using tiles with intricate blue and white patterns. Later in life, trips to the museum became opportunities for active learning. Melville translated the facts and numbers on display into vivid imagery, enabling Richard to visualize and remember the details, such as a Tyrannosaurus Rex that couldn't fit its head through a window. Understanding the how and why of the world around them was a central part of Feynman's education. Melville instilled in Richard the value of observing and comprehending things firsthand, rather than simply memorizing facts. While on a mountain hike, Melville challenged Richard to identify different birds and used the names of each bird in various languages to demonstrate the importance of direct observation. He emphasized that the name alone could not explain the bird's characteristics or behavior, and true understanding came from studying the creature itself. This approach to learning stayed with Richard Feynman throughout his life. While serving on an advisory board for science textbooks, he became frustrated by vague descriptions that lacked depth. For instance, a passage stating, "friction causes shoe soles to wear away," should be more accurately explained as, "the grooves on a sidewalk grip chunks of shoe leather and tear them off." Feynman's relentless pursuit of clarity and understanding was a direct result of his upbringing and fueled his passion for teaching others to see the world through the lens of a true scientist. The Feynman visualization technique. Richard Feynman, a renowned physicist, excelled in math competitions despite struggling with other aspects of life. His success was attributed to an innovative visualization technique where he imagined himself as the subject of the problem. This approach helped him quickly arrive at accurate solutions without relying on traditional methods or unnecessary calculations. Feynman utilized this visualization skill throughout his life and career, setting himself apart from other physicists by envisioning himself as atoms or subatomic particles to gain unique insights into complex problems. Richard Feynman's high school experiences revealed his natural talent for mathematics, as he outshined his peers in the often intimidating Algebra League competitions. While classrooms emphasized the importance of showcasing problem-solving processes, math competitions prioritized efficient, accurate solutions. Conventional methods proved cumbersome in such fast-paced environments, and Feynman thrived using shortcuts powered by visualization techniques. Contrary to his classmates who frantically performed calculations, Feynman merely noted his final answer. He gained remarkable insights by picturing himself as the subject of the problem, enabling him to bypass inconsequential details. For example, when confronted with a problem about a lost hat on a rowboat's upstream journey, contestants were given the water and boat's velocities. However, Feynman visualized himself as the hat and realized the return trip would take the same time, 45 minutes, regardless of extraneous information. Feynman's visualization expertise continued to serve him well in his storied career as a physicist. Colleagues often noted his uncanny ability to solve intricate problems by empathizing with atomic or subatomic particles, asking what decisions he would make if in their place. This unorthodox yet highly effective approach set him apart from others in his field, showcasing the power of visualization in finding solutions where traditional methods falter. Feynman's journey to physics. As a young mathematics prodigy, Richard Feynman began his academic pursuit at the Massachusetts Institute of Technology, MIT. However, during his time there, he discovered that math wasn't the right fit for him as it became too abstract. Instead, he shifted his focus towards physics, where his passion for problem-solving and intuitive understanding of formulas deepened. This new devotion to theoretical physics negatively affected his performance in art history, English, and music, subjects he struggled with due to his upbringing. He even resorted to cheating during exams to cope with these challenges. Despite facing potential rejection from Princeton for graduate studies due to his low scores, Feynman's journey continued, and he went on to become a world-renowned physicist. Feynman's Manhattan Project Odyssey. During World War II, the race to create an atomic bomb was on, and Richard Feynman, a 25-year-old physicist, joined the Manhattan Project to tackle the problem of nuclear chain reactions. Feynman's unorthodox problem-solving and leadership skills helped propel the development and success of the world's first nuclear weapon. Ultimately, Feynman's team contributed critical research in preventing premature detonation and calculating the precise uranium mass necessary for a chain reaction. In the early years of World War II, there was a buzz about the potential of splitting the atom to create a devastating atomic bomb. Top physicists around the world didn't question if it was possible, but when it would happen. To develop the world's first nuclear weapon, a secret facility was established in Los Alamos, New Mexico, housing many of these brilliant minds. Richard Feynman, a promising young physicist, was recruited for the Manhattan Project in 1942, while completing his graduate studies at Princeton. Tasked with determining the uranium quantity needed for a nuclear chain reaction, Feynman quickly rose through the ranks. His unique perspective and innovative thinking earned him the leadership of his own team, something typically reserved for veteran physicists. Encouraging his team to explore unconventional solutions to complex problems, Feynman gained their trust and respect. Though initially met with skepticism, his theories often proved to be accurate, leading to his team's full confidence. The real challenge wasn't merely in making calculations to build the atomic bomb, but in dealing with the physical materials involved. Miscalculations of a metal's melting point could lead to catastrophic consequences. Addressing these concerns, Feynman's team produced crucial research in preventing bombs from detonating prematurely in determining the critical mass of uranium required to initiate a nuclear chain reaction. Their tireless work paid off, and on July 16, 1945, the first atomic bomb was successfully detonated over the New Mexico desert. The Manhattan Project, guided by the brilliance of physicist Richard Feynman, had forever changed the course of history. Mastering intuition like Feynman. Renowned physicist Richard Feynman's brilliance stemmed from his outstanding understanding and intuition of mathematics. His visual problem-solving approach, combined with his uncanny ability to see color when composing formulas, allowed him to develop innovative solutions to complex problems. In 1947, Feynman introduced his diagrams, simplifying the study of quantum physics by effectively replacing unnecessarily complex calculations. Despite the clear genius of his work, it remains challenging to convey the vital details in layman's terms, as showcased by his response to a reporter after winning the Nobel Prize for Physics in 1965. Just like a musician who becomes one with their instrument after countless hours of practice, famed physicist Richard Feynman had honed an intuitive relationship with complex science. He spent endless hours visualizing problems, which granted him superb algebraic knowledge and an ingrained comprehension of physical forces. This exceptional understanding allowed Feynman to work freely within theoretical science. He easily translated physical interactions into formulas, and vice versa, by picturing a vast array of objects interacting over both time and space. Interestingly, Feynman often saw colors, such as dark X's or violet N's, while composing formulas, although he didn't know if his students experienced the same visuals. In 1947, Feynman revolutionized the way quantum physics was studied by introducing his Feynman diagrams. Resulting from his work on electromagnetic fields and their interactions with charged particles, these diagrams provided a brilliantly simplified method to understand complex equations. They eliminated the need for complicated calculations in academic articles on quantum physics. However, translating the significance of his work for a general audience proved challenging. When Feynman won the Nobel Prize for Physics in 1965, reporters flocked to him for an explanation of his diagrams. Despite his attempts, his contribution remained bewildering to those without a scientific background. Frustrated by a request to summarize his work in just 1 minute, Feynman quipped, "Listen, buddy, if I could tell you in a minute what I did, it wouldn't be worth the Nobel Prize." Feynman's revolutionary teaching. Famed physicist Richard Feynman was known for his unconventional teaching methods, which set him apart in the world of physics education. At Caltech, he provided a unique experience, diving deep into concepts and visualizations rather than memorizing names. Though his course was tough for many undergraduate students, professors and graduate students eagerly took up any available spaces. His lectures, transcribed into the renowned Red Books, greatly impacted physics education and provided the world with the tools we still use today for problem-solving and understanding quantum mechanics. During his 2-year stint at Caltech, renowned physicist Richard Feynman changed the game of physics education by offering an unorthodox and immersive learning experience. His approach drew students into a reimagined world of physics, emphasizing deep understanding of concepts, forces, and their interactions. This focus on understanding rather than mere memorization led to students grappling with visualization techniques and problem-solving methods. As a result, many undergraduates found Feynman's course challenging, and some even dropped out. However, this didn't concern him as his teachings attracted eager professors and graduate students to fill the vacated seats. Recognizing the immense value of his courses, attendees diligently transcribed Feynman's lectures, which were later published in a series known as the Feynman Lectures on Physics, or simply as the Red Books. These publications garnered much attention, influencing numerous universities to incorporate them into their curricula. Despite being considered too complex for most beginners, the books significantly impacted many professors, who credited them with reshaping their perspectives on physics. Feynman's game-changing contributions to quantum mechanics focused on the importance of pragmatic knowledge and problem-solving skills over just providing the right answers. These teachings have left an indelible mark on the field, equipping future generations with essential tools and methods for understanding and analyzing experimental data. Today, scientists continue to lean on Feynman's techniques, appreciating the lasting legacy of his innovative approach to physics education. The Unconventional Genius. Richard Feynman, known for his unique approach to life and academia, was not your typical scientific genius. From his penchant for bongo playing to his storytelling capabilities, he attracted attention beyond his scientific contributions. As a fiercely independent thinker, Feynman intentionally avoided the work of others, believing it limited his innovation. While this approach generated criticism and disbelief among peers, his path fostered true originality and innovation. Even among the most celebrated scientists, Richard Feynman stood out with his distinctive characteristics. His fascination with bongo drums, for instance, began in Brazil during a sabbatical. Although he despised most modern music, he loved the bongos due to their scope for improvisation and creativity. Eventually, he even gained enough proficiency to perform with local bands. Another notable aspect of Feynman's persona was his talent as a raconteur, recounting enthralling stories that were later compiled in his books. Surely you're joking, Mr. Feynman. And what do you care what other people think? Despite slight exaggerations for storytelling effect, these books captured his true essence and became bestsellers, an unexpected achievement for a scientist. Possibly Feynman's most controversial trait, however, was his deliberate avoidance of others' work to preserve his original thought process. He intentionally challenged conventional approaches by crafting solutions from scratch, perhaps at the expense of integrating existing knowledge. While allies and detractors alike recognized Feynman's brilliance, some viewed his solo problem-solving as unproductive, particularly given he often left his innovative ideas unpublished. Nevertheless, Feynman's unorthodox approach has a valuable lesson: independent thinking is the cornerstone of genuine innovation. Though it might not guarantee success, pursuing a nonconformist path encourages authentic originality, an attribute that Richard Feynman personified and championed throughout his distinguished career.
Richard Feynman's remarkable life bears testimony to not only his exceptional talent but also to the power of determination and curiosity. Born with an innate love for science fostered by his father, Feynman became instrumental in various breakthroughs, including the Manhattan Project and the development of his innovative Feynman diagrams. As an engaging and passionate educator, he reshaped how physics was taught and left a lasting impact through his lectures. Although his methods were at times unconventional and even controversial, his relentless pursuit of knowledge and unique take on problem-solving remain an essential part of his legacy. Weaving together his professional achievements with personal anecdotes, this summary provides a captivating glimpse into the life of a pioneering force in the world of science.